Everyone, I am from JSS College of Arts, Commerce and Science, Ooty Road, Mysuru, and I am going to present a seminar on the topic Fundamentals of UV Visible Spectroscopy and Emphasis to Electromagnetic Spectrum and Electronic Transition, Charge Transfer and Ligand Field, presented by Anusha from first MSc. So now let us know what is spectroscopy. Spectroscopy, it is a branch of science that deals with the study of interaction of electromagnetic radiation with the matter. Spectrophotometer, it is an instrument to design the measurement of spectrum of a compound. UV is of range of radiation 200 to 400 nanometer and visible region of radiation of 400 to 800 nanometer. So now what is UV spectroscopy? UV spectroscopy, it is a measurement of attenuation of beam of light passing through a sample or after reflection from the sample surface. So first let us know what is the principle of UV spectroscopy. UV spectroscopy, it is an absorption spectroscopy and it is based on the phenomenon of electronic excitation. So let us now when UV radiation is passed through the sample, the atoms or molecules absorbs the energy and moves from ground state to the excited state. So if it occurs in a residual radiation, when it is passed through the prism, there we can observe the gap in the spectrum. It is called as absorption spectrum. So thus the excitation is detected by the detector and amplified and then recorded. So now let us know the components of the instrument. First one is light source, monochromator, sample holder, detector, amplifier and recorder. So these are the schematic representation of the UV spectroscopy is like this. First we have light source, monochromator, sample holder, detector and recorder. The basic requirement for this is light source. When we pass a polychromatic radiation through the monochromator will convert a polychromatic radiation into a monochromatic radiation. That is, only a single wavelength can be passed to the sample holder. The sample containing the sample holder, then it will be sent to the detector, and detector will get detected and then sent to the recorder. It will be in the form of electrical signal like graph. Now light source, deuterium lamp, which is used in the UV region of radiation of for about 200 to 400 nanometer, and next tungsten halogen lamp, which is used in the visible region of radiation for about 400 to 750 nanometer. Next monochromator. Monochromators are the device used to resolve wide band of polychromatic light radiation into narrow band of monochromatic radiation. Namely, there are three types of monochromators such as filters, prisms and gratings. Sample holder. Cuvette is used as a sample holder here and it is made up of pods. Detectors will detect and it will convert light energy into electrical signal that are displayed on readout devices. First one is, there are detectors such as barrier layer cell, phototube, photomultiplier tube, thermocouple and balmometer. Several types of detectors can be used, but most commonly used detector, that is photomultiplier tube. The end component of the instrument of UV spectroscopy, it is amplifier and recorder. Amplifier will amplifies the signal coming from the detector and records, then it is displayed on the readout device. Now, what is the use of UV spectroscopy? UV spectroscopy, it is used for the detection of functional groups, detection of impurities, qualitative analysis, quantitative analysis, single compound without chromophore, and it can be used in the drugs with chromophoric reagent, and it helps to show relationship between different groups. It is useful to detect the conjugation of the compounds. What is spectrum? Spectrum is a group of different wavelengths and different frequencies constitutes the electromagnetic spectrum, and there are different types of radiation such as infrared radiation, UV radiation, waves and visible radiation. These all constitutes the electromagnetic spectrum. So when a ray of light is passed through the prism, we can observe the colors are produced there. So it is called as visible spectrum. And the thermal radiation of higher wavelengths and high temperature, it is called as infrared radiation. So ultraviolet radiations are not visible to a human eye because of their shorter wavelength. They are different from the production and properties, but also they are having a common properties or features like when they are placed in the oscillatory electric and magnetic field, they are perpendicular to each other. So this is called as electromagnetic radiation. In So this is called as electromagnetic radiation. In electromagnetic radiation, the electric field and magnetic field oscillate perpendicular to the direction of propagation of radiation. All the electromagnetic waves are transverse in nature, and all the electromagnetic radiation will travel with the same speed. So the speed of radiation is equal to the speed of light in the vacuum. So the value of the C will be equal to 3 into 10 power 8 meter per second. The waves traveling with the velocity of light and consisting the oscillating electric field and magnetic field, and also the perpendicular to the propagation of direction. It is called as electromagnetic waves, and such waves with different range of frequencies, it is called as electromagnetic spectrum. So this is all about the electromagnetic spectrum. Now the another topic is electronic transition. It is nothing but where an electron can jump from lower energy state to higher energy state. So now by taking an example of this object, that is the object with green color, now when we irradiate the visible light with the visible radiation is made to fall on this object, uh, and with the intensity of I naught, and the remaining radiations coming out of the object, that is IT is nothing but the intensity of the transmitted light. This intensity of the transmitted light is made to fall on our eye, so we can observe the green color. What the color we are observing is not only the color corresponds to the green color, but it is actually the complementary color of the green color. So the radiation which is absorbed, that means the object is going to absorb some radiation, and the color remaining is the complementary green color. So the question is like, why this object only appears in the green color? That means because it absorbs the visible radiation, that means it absorbs the visible radiation. That absorbed radiation is used to produce the electronic transition within the molecule. So if any molecule is colored and absorbs the radiation, it is mainly because of the electronic transitions. So there are 6 type of transitions, namely pi to pi star transition, n to pi star transition, sigma to sigma star transition, n to sigma star transition, charge transfer transitions, and ligand field transitions. So let us study it. Now sigma to sigma star transition. These will have only sigma bond, so they undergo sigma to sigma star transition. Molecules like cyclohexane will have sigma bond, so it undergoes sigma to sigma star transitions. And alkanes like propane will have sigma bond, so they undergo sigma to sigma star transitions. These type of molecule will fall under less than 200 nanometer. So it is called as vacuum UV region. So this type of molecules can undergo sigma to sigma star transition. Now pi to pi star transition. The molecule to possess a pi to pi star transition, it should have pi electrons. Now here I have considered the alkenes like ethene. Ethene is having both pi and sigma bonds. So apart from sigma to sigma star transitions, here ethene will produce a pi to pi star transitions. 1,3-butadiene is also having a 2 pi bonds, and it will also produce a pi to pi star transitions. And similarly benzene is having 3 pi bonds, and it will possess a pi to pi star transitions. And another one is conjugated polyethylene system. It is also having a pi bonds. It will also possess a pi to pi star transitions. So these all transitions will fall under the UV visible region, except ethene, because ethene is having a lambda maximum of 175 nanometer, and all these like 1,3-butadiene, benzene, and conjugated polyethylene system will fall above 200 nanometer. It will be having UV visible region. So pi to pi star transition acts as a chromophores. This extended conjugation will have a bathochromic shift. So this will increase the capacity of the chromophores. Next is N to sigma star transition. In N to sigma star transition, in ethanol, we have both N electrons and sigma electrons. So it possesses N to sigma star transition. In the same way, ethanamine and ether will also possess N to sigma star transitions. Why? Because if a molecule is having a heteroatom attached to the single bond, will possess N to sigma star transitions. These type of transitions requires the higher energy, and these type of transitions will fall under the region like less than 200 nanometer. So this is all about the N to sigma star transition. Because why in ethanol we have heteroatom, in ethanamine we have heteroatom, In the ether also we have heteroatom. These are attached to the single bond. So this all possess n to sigma star transitions. Now Now, N to pi star transition. If a molecule to possess a N to pi star transition, it should have both N electrons and pi electrons. So the compound like acetaldehyde, it is having all the type of electrons like N electrons, pi electrons, sigma electrons, all types. So it possesses N to pi star transitions. Like the same way, I have took acetic acid. Acetic acid is having N electrons and pi electrons. Like carbonyl compounds, acids and acid derivatives will have the uh, will possess a pi to pi star transitions. In the same way, acetonitrile also having a pi to pi star transitions. In N to sigma star transition, in ethanol, we have both N electrons and sigma electrons. So it possesses N to sigma star transition. In the same way, ethanamine and ether will also possess N to sigma star transitions. Why? Because if a molecule is having a heteroatom attached to the single bond, will possess a N to sigma star transitions. These type of transitions requires the higher energy, and these type of transitions will fall under the region like less than 200 nanometer. So this is all about the N to sigma star transition. Because why in ethanol we have heteroatom, in ethanamine we have heteroatom, in the ether also we have heteroatom. These are attached to the single bond. So this all possess N to sigma star transitions. Now Now, N to pi star transition. If a molecule to possess a N to pi star transition, it should have both N electrons and pi electrons. So the compound like acetaldehyde, it is having all the type of electrons like N electrons, pi electrons, sigma electrons, all types. So it possesses N to pi star transitions. Like the same way, I have took acetic acid. Acetic acid is having N electrons and pi electrons. Like carbonyl compounds, acids and acid derivatives will have the will possess a pi to pi star transitions. In the same way, acetonitrile also having a pi to pi star transitions. Now next is energy diagram for the transitions. Like we can observe in this diagram that sigma to sigma star transition is very high energy gap, and it requires very high energy for the transition. So in the same way, N to pi star transition, there is a less energy gap and we require less energy. So next is chromophores. Chromophores, molecules having unsaturated bonds of free non-bonding electrons that can absorb radiation of relatively low energy and which imparts color to an organic compound. This is called as chromophores. Oxochrome means it is a functional group that does not absorb in UV region and but has the effect of shifting chromophore peaks to longer wavelength as well as increasing their intensity. Bathochromic shift. Shift of lambda maximum towards the longer wavelength, it is called as bathochromic shift. Hypsochromic shift means it is a shift of wavelength towards the shorter wavelength. Hyperchromic shift means it is an effect leading to increased absorption intensity without altering the lambda maximum. Hypochromic shift, it is an effect leading to the decreased absorption intensity without the changing of the lambda maximum. So next is the charge transfer transitions. These charge transfer transitions are responsible for the intense UV absorption of large number of inorganic and organic species. To exhibit a charge transfer transition, it is necessary that one of the components have electron donor characteristics and other have acceptor property. Ligand field transitions. Ligand possess sigma orbitals such as sigma star, pi star and non-bonding n orbitals. If the ligand molecular orbitals are full, charge transfer may occur from ligand orbitals to empty or partially filled metal d orbitals. The adsorptions that arise from this process are called as ligand to metal charge transfer bands, that is MLCT. Forbidden transitions may also take place by giving rise to weak absorptions. If in low oxidation state and ligand possess low lying empty orbitals. For example, let us take an example of cyanide. Then a metal to ligand charge transfer transition may occur is common for coordination compounds having a pi acceptor ligands. And these are my references.